Auzubillahi Bismillahirrahmanirrahim. Start with the name of Allah Almighty, who is the most beneficent and merciful. First of all, I want to say Assalamu alaikum to everyone. I hope that all of you will be fine. All of you going well in your life. So this is the second part of my video. In the first part, we have already discussed about the first type of the collision theory. So the first type of the collision theory, that is called bimolecular collision theory, we have already discussed in my first video. So this is my second video. In this video we will discuss about the transition state theory. This is the second type of the collision theory. So in a transition state theory, first of all, I want to give all of you a most wonderful concept about the transition state theory. So in a transition state theory, there are two reactants. Those react with each other to form an activated complex. Activated complex is a highly energetic and highly unstable. It means that there is a lot of energy which is required to break the activated complex. But when the activated complex is decomposed, then it gives us product. So the formation of the first activated complex must be necessary in this transition state theory. So this is a wonderful concept. First of all, reactants react with each other to form an activated complex. Activated complex decompose to give us product. So now we will discuss about the assumptions of the transition state theory. So the first assumption of the transition state theory is that the molecules should be collide with each other. The molecules should be collide with each other to form activated complex. The molecules should be collide with each other to form activated complex. The second is activated complex is highly unstable and highly energetic. Activated complex is highly unstable and highly energetic. Third is a lot amount of energy is required to breach it. A lot amount of energy is required to breach it. When we provide the lot amount of the energy is required to break the activated complex, then the activated complex decompose to gives us product. Let us consider there are two reactant species. First is called A and second is a B. These are react with each other to form an activated complex. Activated complex is a highly unstable and highly energetic, so there is a lot amount of energy is required to break it. So when we provide the sufficient amount of the energy to the activated complex, then the activated complex is decomposed to gives us product. So the reaction between the reactant species and the activated complex is a reversible reaction, but the reactions between the activated complex to the product is a forward reaction. So during the reversible reaction, the constant is K star. So K contains a star at its exponent power. This star means this is a very unstable. So this activating complex also contains a star. So this star means this is very unstable and highly energetic. So now we'll discuss about the other equations of the transition state theory. So we know that small k, this is a Boltzmann constant, which is equal to RT over NaH into K star. So K star is a unstable rate constant. So R is a general gas constant, T is the temperature, Na is the number of the moles, H is the Planck's constant. So we know that K star, which is equal to e raised to power minus delta G star over RT. So we also know that delta G star, which is equal to delta H star minus T delta S star. When we put the value of delta G star in this equation, then we put the equations, so then we get K, which is equal to RT over NaH into e raised to power delta S star over R plus delta H star over RT. Since when we take a logarithm of these equations, then the equation becomes ln of K, which is equal to ln of RT over Na small h plus delta S star over R plus delta H star over RT. So this is the final equation of the transition state theory.